Ladies and gentlemen, please welcome Steve Guggenheimer and John Shuchuk.
All right. Good morning, everybody. Welcome to day 2 of Build. My name's Steve Guggenheimer. My colleague is John Shuchuk. They often call me Googs and Shu. Bad joke there. We'll let that one go. We hope you guys had an outstanding day 1, and our goal is just to keep the momentum going on day 2. First thing I want to do is thank our DJ, Alan Smithson. I thought he did a great job. The emulator board that he had here is only 25 in existence. He helped co-create that. He'll be at the party tonight, so if you want to make your own mixes and use the board, you're welcome to come out and see him, put it to the test, and have a little bit of fun with that. Now, what John and I wanted to do is sort of take some of the conversations we have on a regular basis and bring those to life. As I hope you got a sense from the video, we basically spend all of our time talking to developers, from students to startups to large and small ISVs, to folks who work in large and small commercial enterprises, people who build software for a living. And the trick here is to take those many conversations and to bring them to life. They range from types of apps, to technology areas, to business models, to tool chains, and more. John, what do you think about that as a starting point?
Yeah, when Googs and I are out there talking to developers, I mean, one of the things that's extremely exciting for folks is just the vast array of capabilities that are out there. Different kinds of devices you can target, different cloud platforms with PaaS, with IaaS, and then these new emerging platforms as software as a service like Salesforce or what we're doing with Office. And so when they come and we have those conversations, it's almost never about this Microsoft technology or this particular product. It's about how do we put all this stuff together to build great applications and make applications that help us make money and be successful. Right. So we thought we'd share a little bit about how those conversations are going, how we're putting these pieces together to build world-class next-generation apps.
And so that'll be our framework for today. You see behind me a set of the conversations that we're going to bring forward. We're going to have some of our colleagues come out and help us throughout the morning. We're going to try and bring these to life through 2 things. As much as possible, use code that partners or others have built, ISVs that we've worked with. Second, do as many demos as possible. We always try and get as many in a short time frame as possible. And third, show code. I saw a little meme yesterday that said there was a lot of code, maybe too much, and I don't know how other folks run their dev conferences, but if you didn't like the coding yesterday, you're not going to like today because we'll probably show more. And with that, I think we ought to dive in. So I wanted to start off with some fun, the media and music space. One of the cool things that's going on is the mixture of sort of IoT, predictive analytics, Bluetooth, and it's enabling some crazy ideas. This is one that our friends at Music showed us, and when I got a chance to work with this, you see the drum kit on the surface? You see the virtual drums? Like, things possible I would have never thought of. And the cool thing here is, obviously, I'm not a drummer, but the folks at Music, they're working with folks who do this for a living. Let me show you a little bit about what they're talking about.
Thanks, Googs. This is Questlove of The Roots and a member of the Music team. I just want to say I'm really excited that we're working with Microsoft on our motion instruments and our accessories. And personally, I can't wait to see all the things that you guys create using Xbox and your mobile devices with our game-changing technology. And let's work together on the future of music, the future of gaming, and the future of technology. Let's go.
So, pretty cool stuff. Jason Hardy and the guys at Music, let's a little thumbs up for Questlove. This is something we couldn't have contemplated a few years ago, so there must be some work going on between what they're doing and what we're doing to make this possible.
Yeah, I mean, think about this particular application. You got professional musicians, you're using these devices with accelerometers, they're doing predictive analytics and a whole bunch of other pretty complicated stuff, but at the end of the process, what they've got to do is they've got to play a sample and they've got to do it quickly. Now, what I've got on the screen here is some code that we would have had to write back in Windows 8. This is some pretty complicated C++ code, you know, page upon page of it. All of this to go take that event and play that sample. And even when you were done with this, you would have had a problem. the latency would have been a little high. So the engineers in Windows have been hard at work. They've been optimizing the video display channels, the audio channels, and they've actually made it incredibly easy to program. So here's some new APIs that we're introducing. Here's the new audio graph API. This will do audio processing. Notice we can create a device output. Here's where some of the magic happens right here. Notice we set the quantum size selection to the lowest latency. This is what lets the thing play. We connect it to an output device, and then we go load the samples here and build the file nodes. And that's the core of one of these applications. Obviously, more stuff going on with the Bluetooth stack and so on. But let me actually just show you this thing. So here's a quick example, and I'm just going to use touch, and I can now play on this. Oh, hey, Steve, you appeared on the screen. Now, last year, when we were doing this, I remember you wanted to switch gears a lot. So
let's switch gears. Let's switch gears. Let's switch gears. Helpful, John. Yeah, this is why we don't let him play with the music side. Maybe we'll give that to Alan later on for tonight. Yeah. All right, so let's switch gears because the clients, sorry, it just was there. The client side is one area of innovation. The other is obviously on the cloud side and with streaming media overall. Yesterday we streamed out over Channel 9 the video from this presentation, all the rest of them. We hit about 300,000 plus users, about 75,000 concurrently. And for us, that's big scale. We're pretty excited about that. This year, working with NBC, we did the Super Bowl. It was over 1.2 million concurrent users. So when you think about over-the-top transmission, when you think about streaming media, music, video, all of it, it's coming together now, and a lot of work's going on the cloud side for that.
Yeah, now what you can see here is once you've created great video, great audio, the ability to get it out across all the different platforms is very important. And we're looking at the actual streaming that's coming through the Azure Media Services, the Channel 9 discussion, so there it is, doing cloud encoding and a whole bunch of other stuff. What I really wanted to do, though, was just spend 1 second. Here's a very simple player where we can see what's happening. I just want to show you the code behind this. This is what it takes to go build one of these cloud-distributed, high-scale, DVR-based systems. All of this code we're making available. It's incredibly easy to use, and again, at the core of some of these huge projects like the Olympics.
Right. And the nice thing with all these pieces is we're starting to see a set of ISVs building on them and give us feedback and help us along. Let me run a video from a partner or an ISV that's building on top of this and helping us learn more.
Propellerhead is a leading developer of software for music making, both on desktop and mobile, allowing musicians of any skill level anywhere in the world to make music together. In a cloud-first and mobile-first world, our customers expect us to be cross-platform. Microsoft allows us to develop on one device and rapidly deploy across other devices. We started Propellerhead 20 years ago, and our aim was to democratize music making, to make it available to anybody regardless of their income or skill level. In a way, deploying on mobile brings us back to those roots, and we're able to deliver for free incredibly powerful music making tools. It's a race, and you're as music brings people together, so does technology. With these technologies, we'll be able to help people make their musical dreams come true, anywhere in the world, on any device, at any time. We're really excited about what all this technology can do for people going forward.
So my thanks to the folks from Propeller. Look, we're getting feedback from networks. You see TSN, CTV up here, RDO and TuneIn and iHeartRadio are giving us help on the client side. So we're getting a lot of feedback on how to make all of the underlying and underpinnings for what we're doing better and better and better. So I'm going to move off of media now, and given our audience, we know a lot of you work in the commercial space for a living. We'd spot, before we get into some of the deeper details, we do a couple commercial pieces. So first off, let me just say, hey, we've got great partners here who are also giving us feedback. We heard about some of them yesterday with SAP, and you saw DocuSign on stage. GE's been doing some great work with us. Salesforce, yesterday we saw the integration with Office. They're also building a Windows 10 application, working with us not just on the application, but on the SDK. There's also infrastructure. We saw Docker yesterday. We've done some work with Mesosphere. I wanted to talk a little bit about Autodesk at this point, because one conversation that is bridging, I think, from consumer to commercial is the area of 3D printing. This is an area where we have a lot of discussions, and this is one of those areas where today we do a lot with 3D printing for prototyping or modeling, and folks want to move to the area of manufacturing. So really make that step into a commercial space. Now to do this, we have to get all the systems to work together. You have to get the software to work with the hardware, the printers themselves, as well as the materials. And today it's not quite as smooth as we'd all like. So we've done some work working with Autodesk. Autodesk has been building an engine they call Spark. And Spark allows us to have a platform across the software, the hardware, and the materials with a set of APIs in an open way that we can all work on and use. And what I'm happy to announce today is we're going to integrate that Spark engine into Windows 10. So now we have a common platform we can all work from and build on as we want to go out and do 3D modeling. And the cool thing here is they're starting to build sort of a line of 3D printers that take advantage of the Spark engine. This is the first time anyone's seen one of these new Ember printers. I love the fact that on the Autodesk side, they do nice design. And when you think about manufacturing, you can think about lots of scenarios. Up here you see an earbud. The professional musicians, the race car drivers, they have these custom-made ear inserts. And the notion of moving from doing this as sort of a project through multiple phases to basically having a manufacturing ability to do this is the direction we're headed in. So I'm pleased with the work we're doing with Autodesk. I wanted to highlight that today because that's an area where I get lots of questions, we have lots of fun, but we're going to move from modeling, I think, to manufacturing in the near future. Now, one other one that I think, when I think about commercial then, is true line of business applications. And here, you can take a vertical scenario by industry or horizontal. You can think ERP, CRM, supply chain management, SCM, et cetera. And so I thought we'd take a horizontal solution, in this case ERP. Our friends, ISVs in the Northwest called Acumatica, who build a cloud-based ERP. Why don't you show us what we have here, John?
Yeah, so many of these vertical systems at the core have reporting. And here what we see is a typical sales order summary. And you know, it's got a lot of information, but
as usual, it's close, John, but I need a couple of changes.
yeah, and normally as a developer, often those changes are things that I would have to go in and do relatively manually, code it up, add it into the list of reports that these folks can do, and that means that I'm not necessarily working on the broader aspects of the project. Reporting can take a lot of effort. So we were having that conversation with Acumatica. How could we leverage what's happening in the cloud, this new distributed world, to take what they've already got and make it much better? And so we did this pretty cool thing, which is we added to their query system the ability to expose all their data out to the world through the internet, through REST interfaces. It's called OData. And the way we did that was actually pretty straightforward. We've got what you're seeing here is the actual code inside of Acumatica. They have an object relational model. They hooked up a simple library that exposed that ORM through OData. And let me show you kind of how cool that is. Here's the Power BI Builder, which is one of the tools that can consume OData. Lots of other things, Excel and other stuff can do that. All I need to do is I just click on this and I go add an OData feed and I connect to it, type in that URL to the Acumatica data, and off we go with now the new Power BI tools. In fact, I think we've got it running over here,
yeah.
So you can...
So we might as well have some fun since we have all this great new hardware to play with. Now, as the end user, I really don't care what John's doing. I just want to be able to get access to the information. And so I've got a Surface Hub here. Oh, sorry, let me reboot it. I've got my Surface Hub here. I have a smooth inking on this, so I could choose to type in, but you know what? I'm just going to go up here, press, and I'm actually just going to ask for sales by city. Let that come up. And you know what? I'm curious. I'm going to do, I'd like to see that as a map, so I'm going to say as map. And you'll notice it just automatically goes. So for me as the end user, I can sort of pick the reports I want. I can zoom in if I want. It's a pretty cool way to take what John's working on and not have to go back and ask him over and over again for reports. Now, John, this is pretty cool. What I saw yesterday in Satya's section was he also hooked into the Office graph. So what I'd really like to do is see this by user. In fact, I'd like to see this by your team.
Yeah, so really what we're talking about is doing dynamic joins across different data sets using the OData protocol underneath the hood. What I've got here on the screen is a very simple single-page web app. This is the kind of thing you would do if you were talking to a Facebook API, anything. And it's pretty straightforward. You do a redirection to a login page, you get back a token, you use that token to access information. But here's where the real work occurs. We're going out to that new Office graph. We're going to graph.windows.net. We're taking our me token, and notice I'm looking at the direct reports. So let's actually just run that. And what we can see here is we want to go retrieve these things. It reaches out, it gets the data, we've printed out the data, and as you can see, here's the JSON that comes back. This is pretty clean, pretty easy to parse stuff. Anybody in almost any language can take advantage of this. But again, this has been put out in a way that's consumable by a lot of products. It's got this OData characteristic. In fact, we've also linked that one up to the same Power BI, so now we can do those queries.
Yes, you see the Microsoft Graph API, we've hooked it up as well. So here I can now go orders by manager. And there we see the orders by manager, and you'll notice this is the true magic of software. John is selling more than anyone else. And all of us know in this room that John is not selling anything to do with software right now. He's completely doing the coding. So I like the fact that magic of software allows him to sell more. And really that works out as a nice connection between the end user and John on the back end of this piece. So this is a good spot. I think we've done a little bit to get going on the consumer commercial 2 conversations we have on a regular basis. One thing we heard a lot of feedback on yesterday that people want to talk about is Windows and building for Windows 10, in particular taking advantage of the Universal Windows platform as well as some of the bridges. So with that, I'm going to introduce our good friend David Treadwell to come on out. David's coming from that way, and help us out and take us on a journey through Windows 10. David, nice to see you. You're up, buddy.
All right, man.
Good morning, Build. So at Build, we've been talking a lot about our conversations with developers. And I'd like to tell you about a conversation that Terry and Kevin Gallo and I had last summer with one well-known developer, a guy named Bill Gates. We were reviewing with Bill our plan for making Windows 10 great for developers like you. As you might imagine, a review with Bill is always a big deal, so we were well prepared, but we were also nervous. One of the points that I made is that we've been getting lots of feedback from people like yourselves that they didn't like one thing about the modern platform in Windows 8, and that's that it really only supported full-screen applications, no windowing. Full screen is great on a smaller screen like a tablet, but many people like large screens, multi-monitor setups. I love the 3-monitor setup that I have. So I told Bill, one of the things that we're doing in Windows 10 is we're bringing back this fine feature from 1986, resizable, overlapping windows for apps. Woo. And Bill paused, and he looked at me kind of intently for a second, and then he said, "Wow, that's a really great idea. You know what we should do? We should name the product after that feature." So I told him that the joke in the engineering team is that we really should have called it Window 8. True story, happened just like that. And that story does show something important. While it is valuable to have experiences that span multiple devices, we as developers must put the user at the center of these experiences. What works great on a tablet may not work great on a huge modern desktop monitor. This important idea from our conversation with Bill carries through both of the developer conversations that Kevin and I are excited to talk with you about today. First, how can Windows 10 enable you to provide a continuum of experiences across device types that put the user at the center? And second, how can Windows 10 help you take the code that you have today and reach over 1 billion Windows users with more personal computing experiences only possible on Windows? Let's start by discussing the first one. With Windows 10, the Universal Windows platform now lets you reach the entire family of Windows devices. From laptops and desktops to tablets, phones, HoloLens, Surface Hub, Xbox, and even Raspberry Pi, all with one amazingly flexible platform. Whether a device has a large screen or a small screen or even no screen at all, a mouse, keyboard, touch, a game controller, pen, camera, sensors, you name it, the Universal Windows platform gives you a way to exploit the abilities of the device and create more personal computing experiences for your customers. We've made improvements across the board for developers. It's now easier to design, debug, develop, and distribute your app. Last year here at Build, I told you about how Universal Windows apps could adapt one design across devices, or tailor the design to each device. The Universal Windows Platform in Windows 10 makes this even easier. There's now one design language and one control set across the platform. This gives you a predictable, consistent toolkit for creating your user experiences across all Windows devices. For example, the pivot control, which originated on phone, is now available across devices in a way that works great on each one. The Universal Windows Platform in Windows 10 includes brand new controls too, like a fully featured calendar control. Controls work across screen sizes with mouse, touch, keyboard, pen, and now even game controller right out of the box. And all the controls are accessible to all users. The one design language and one control set make it easy to adopt your app for common scenarios. Things every app designer needs to handle, like window size and input type, are often handled for the platform automatically by the platform for you. For example, menus appear with mouse-optimized or touch-optimized presentation, depending on how they're invoked by the user. But you can write the code just once. The Universal Windows Platform in Windows 10 gives you more power to tailor to each individual device as well. The new Adaptive Triggers feature lets you respond to changes such as window size and automatically adjust your layout, all in markup. Beyond just size, you can tailor based on input, orientation, availability of sensors, app services, or pretty much any other change you can detect. You can even create a totally custom XAML view for each device, all sharing common code. And last year I also told you about how you could share common code for your Universal Windows app across phone and PC. With the Universal Windows Platform in Windows 10, you can now literally write to one universal API and produce one package to reach every device. It's incredibly straightforward as well as flexible. Using feature detection and API contracts, you can take advantage of any device-specific APIs while still writing the overall app to the one universal API. The Universal Windows Platform is really just V10 of the same modern platform you've been using on phones since Phone 8.1 and on PCs since Windows 8. Your code still works. Your concepts still hold true. You can continue writing apps to the Universal Windows Platform in your language of choice, whether that's C, C++, C#, Visual Basic, or JavaScript. The Universal Windows Platform brings together the best of Windows, Phone, and Xbox. Now you can access Cortana and Action Center on the PC. You can print on the phone. You can use Xbox Live services on every Windows device. And there are tons of new things in the Universal Windows Platform as well. DirectX 12, Holographic, Active Pen, Windows Hello. Over 2,500 new platform features, over 8,000 new functions unlock new capabilities for your apps. Now I'd like to ask Kevin Gallo to come show you how to use the Universal Windows Platform to build an app that reaches every Windows device family. Go get him.
Thanks, David. I'm excited because today I'm going to be able to give you a lap around the Universal Windows Platform. What I've done is written a single application that runs across a plethora of devices that I'm going to show you today. Now, I decided to focus on a home remodeling application. I was inspired because my wife and I started a project in our home. And as we were working with a firm to go through this process, I kept thinking about how I could streamline and improve the experience that they had between the firm and with the customer, and really also with the device family that we have with Windows. There's a bunch of things that they could do that would be unique and they could differentiate from their competitors. So let me just dive right in here and talk about this application. So it has 5 phases. It has a design phase, a planning phase, and a capturing phase, then an organizational phase, and then kind of this last phase, which is they present the final product. And they'll ultimately try and and close that. So for this design phase, I think the best device I could think of was kind of a creative sketching device, which is a Surface Pro 3. So here I have that running. And you can see on the left-hand side, I have a split view UI here at the top. I have the 5 phases that I talked about. On the right-hand side is a canvas for me to draw on. So I'll just start drawing, and you'll notice the beautiful ink support that we have with the Universal Platform. And I can go draw my room here, And I'm actually not very good at sketching, but it all is beautiful with this ink, low latency, and you can see it's very fluid. This is all built on the new direct ink APIs that we support on the Universal platform, and this is all hosted inside of an ink canvas. But I wouldn't be the one who really was doing the initial design. Instead, I would have gotten that from a designer. So we can also save and load ink. And when it loads the ink, this is real ink. This is not some image that can't be modified because we want to collaborate on it. So here I'm going to move my pen into selection mode, and I'm going to draw a lasso around that, and then I'm going to use my finger. This app is aware and knows that when I'm using my finger, I'm in editing, I'm not drawing. Because I can also draw with my finger, but here I'm going to differentiate between pen and touch, and then I can go and say, you know what, I really want my entryway to be a little bit bigger. And so I can add my creative, whatever creative I have to this application for us. So let me go show you the code that we wrote to create that lasso. So I'm going to hop on over here to Visual Studio. And what you'll see here is this is my XAML for my design pane. And so all I had to do was add this ink canvas control that's new in the Universal platform. So once I have this in here, then I can wire up some code to create that lasso. So let's go look at how to write that code. There are really three parts that I have, three event handlers that I need to do. My first press when I want the selection, then as I move the pen, I get another set of events, and then when I release it, I need to go perform the operation. So let's start with the code for creating the lasso on my press. So when I press, I'm going to create a polyline. This is the line that I'm drawing for the lasso. I go set some attributes on the line itself. I have to make sure I add the first point. And then I go and I say, for the canvas, I want this to be a selection versus the actual part of the canvas drawing. The ink canvas is smart enough to know the difference between selection and drawing on the canvas itself. Then I'm going to go here to where when I move it, and all I do is add another point every time I move. And that's nice and simple. And then when I release it, I need to process it. And so, of course, never forget to add the last point so it looks right. And then create a bounding rec. Here, what I do is I get the polyline that I drew around it, and I ask the ink canvas to give me all the points that are within that polyline. And that creates this bounding rec. And then I draw, right around that, I draw that bounding rec, and that's all I had to go do. So very straightforward, simple, a little bit of code here, and I have great selection and a great experience on this device. Now, this is not the only device that supports pen. And we know that universal applications run across many devices, and anyone that supports pen will support it. So here, we have the largest of our pen-enabled devices. This is an 84-inch 4K Surface Hub. So let me go load the same application. And so this literally is the same binary running here on the Surface Hub. And I can go and I can draw beautiful fluid ink. Build. I shouldn't have done that. Oh, well. Made an error there. Can't spell. But I can load the same exact thing here. It's all very fluid, beautiful ink, all with the same application. But this is not just for drawing. It really is a phenomenal collaboration device. And having this in the showroom would be a great place to interact with their customers and to kind of not just draw the sketch, but also begin to plan the trip. Because the next phase is going in and out, going to different stores and looking at different materials and carpeting and flooring and countertops and deciding what you want to do. So here in this phase, we're looking at a map. And this is a built-in map control. If you remember from yesterday, Joe showed you our map app. And our map app is using the same exact map control that is available to every developer using the Universal platform. Now, this is a very rich control. I can go move it around. I can stretch it. I can actually do a tilt view. All this works offline. I also have a 3D aerial view built in. All you have to do is change the mode and say you want an aerial view. But I'm going to move back here. So map's not very useful if you can't put anything on the map. So we also have the ability to pin points of interest, or in this case, stores. So I've set up a little filter here where I can go choose what type of stores I want. So they have a list that they work with and partner with. And I typically like more modern stores. My wife likes traditional. But since she's not here, I win this time. We're going to go look at modern stores. Your mileage may vary. And you'll see that I also have a list here because I want to actually see what they are. And then the points of interest just show up on the map. All I had to do was data bind that list to both of these, and they show up. So now I'm going to hop on over here and show you the code that I wrote to create those points on the map. So here I am back in my Visual Studio. and I'm going to go to my planned trip XAML right here. So all I had to do was add a map control, set some basic zoom levels on it, and then create a list box, data binding the stores that I was going to have here in this list box. And then that's all I need to do in my XAML. Then every single time I do the drop down and I choose and I optimize on which ones I want, whether I select all of them, I get a event handler here on my click. And let me just pop in the code here. So I do some simple processing right here. I go through, this is pretty simple, just go see which things are checkboxed, create some queries, for which of the stores we wanted. And then I just go and I update my observable collection that's data bound, and then I update that, and it automatically goes show the points of interest and the list. Very straightforward, easy to add, easy to optimize. But now once I've gone and I sort of planned my trip, I want to go take photos and see the different furniture and carpets and use nice optimized fashion. You just kind of walk around and go. And it's kind of heavy to go lug one of these big things around. So let's go from our largest device to our smallest device, which is our phone, and it's the most portable, so I can bring it with me. So here I'm going to launch the same exact application. And what you'll notice is it has automatically adapted its user experience to run on the smaller form factor and look appropriate on this device. And basically the map is now at the top and the list at the bottom. The menu is now in overlay mode. All of that very straightforward. So let's go see here, go into Capture. And you'll see here we have a new camera API that allows you to go into a preview mode and take a picture. And this conveniently located end table over here is a perfect one that I think I'll put maybe in my living room. So I'll just go, I'll take a picture of that. And I'm able to go say, hey, tell my wife, I think this would be great for our, maybe our bedroom or our living room or something like that. So now let me go show you the code that we wrote to build that adaptive user experience that we've been talking so much about at this conference. So I'm going to pop back here to the XAML I have in that planning page. So what I didn't show you above this is right here, right above the map and the list, they're inside of a relative panel. Relative panel is a new layout container that we've created that really provides a lot of the magic behind the adaptive user experience. It allows you as developers to either dock items, items inside of it to each other or to the side, to the top, bottom, and give you a lot of flexibility in setting attributes. Above this, I've set up a few visual state groups with adaptive triggers that David talked about. And so I have two states. One, when it's between 0 and 599 pixels, and then when it's 600 pixels and above. So my narrow state is that smaller one, and so basically my adaptive trigger says, hey, when it's 0, then it will go basically less than the other one. It will go and do a bunch of setters. And what these setters do is it makes the map go above and the list below, and then take the full width of the screen. When it's 600 pixels, this adaptive trigger will fire and apply these setters. And these setters do what you see on the screen over here, the map on the left-hand side and the list on the right-hand side, and then they take up the full height. So here you can set up a bunch of adaptive triggers based on the size or any other attributes and adapt the user experience very straightforwardly. This is what provides all the magic. Relative panel plus adaptive triggers plus the visual state manager. And that gives you all that richness that you've seen in all these different user experiences over the last few days. So now that we've taken the photos, and we have a bunch of those that we've collected. It's really about arranging those photos and deciding you want to create storyboards for different rooms. Now, when I think about going and creating a storyboard and kind of manipulating lots of different pictures and photos, I think a desktop is a much better device for doing that. Use a mouse, my keyboard maybe to type things. So I'm going to move over to my desktop and show you the same exact application running here. And what you'll notice in this organized phase, first of all, is we're using a pivot. This is, as David said, we've added pivot now to the desktop. There's a great user control for being able to view like the rooms and then be able to assign different things to different rooms. So I can pivot between each of the rooms, and I start to create storyboards for each of these. And they work very nicely with touch as well. And then I think the right way to do this is really to use a drag and drop metaphor, where I'll go to my living room and I'll say, you know what, I don't really like this. I'm going to remove that. So I use right click. That works natural. Then I'll just drag in another one and say, I want this instead. And so here are the floors that I think would be great for it. I'll go to my master bedroom and say, I think fireplace. Everybody think I should have a fireplace in my master bedroom? I think it'd be great to have a fireplace in my master bedroom. So I've dragged that in there as well. And so now I have be able to, basically add a few things here. But on the desktop, it's not just about the single application. It's about using multiple applications and really multiple windows, like David said. So I'm also able to support drag and drop between applications. So here we have the photo application that's built in, but you could also use the File Explorer. So if you had something on an SD card, or if you had a WPF or Windows or Win32 application, all of those would work as well. So we can now drag in, and this will go take this bitmap that I had, or this JPEG I think it is, and it'll go and import it in here and add it to the film strip at the bottom. That allows me to do some of the palette that I'm choosing from for my rooms. So now I'm going to go back to Visual Studio and show you how I implemented all of that drag and drop functionality. So I'm going to move over to my Organize page, and there's the code behind that I've got. So I have a handler called Grid Drop. So whenever I drop it onto that grid, this fires. It's the same exact function that fires whether or not I dragged it from inside the app or from outside from a different application. But I get different content. When I dragged it from the outside the application, I got a bitmap, or I got a JPEG or some sort of image format. Where when I dragged it from inside, I had already a furniture that I had defined in my collection there. So I detect those in two different ways. So when it comes in here, it's one of the if it's a storage item, then I'm going to know it came from outside. So let me drop in the code here and show you how I add it to the list of furnitures. So I go and I find out if there are any items. And then I go and I get the bitmap, I import it. So whatever format, we have a bunch of decoders built into the platform, and they will automatically decode it. Then I have 3 different attributes on every furniture item, which is a name, a description, and then I have this ID that I have, and it gives it a unique identifier for every piece of furniture. And I actually use that later on, so I don't have more than one copy, because nobody wants more than one copy of everything. And then I set the image, and then all I do is add it to the list of captured images. If I actually am dragging it from within the application, I have some code here I've written. Here, the way I do that is I reference just the unique identifier of the furniture, and then I want to assign it to a specific room in the pivot. So I get that ID, what was passed in during the drop operation. Then I go, ask which of the pivot tabs, and those are the 3 rooms that I was having remodeled, it was in, and I just add it to the list of captured images for that room. So very straightforward. I was able to use drag and drop between applications or within my applications as a great way to build an experience that felt natural for someone using a mouse. So now once we kind of get through this phase of, we've kind of created storyboards for each room, what we also like to do is kind of do a slideshow. How do I get a feeling for what that room's going to feel like and the characteristics of that room? So here I'm going to go back and get this side. We have a slideshow mode where if I hit this, it will cycle through all the photos, all the captured images for that room. So I can get a feel for the aesthetic and say, yeah, do they all match or do they not match? Now, while this is great to do for my room, I think it's great also for this customer. I was thinking, wow, if they could build some kiosks and have some of these pre-done, some area there, their showroom that says, okay, here's the kitchens, over here, here's the living rooms, or here's a different type of aesthetic like traditional. They can have these dedicated kiosks that would kind of advertise, some of the ways that their aesthetics works and attract more of their customers and excite them and give them maybe some ideas. And I think the best way to do that is with some dedicated devices. So I suggested we use a Raspberry Pi 2 with Windows IoT Core running on it, because I can run the exact same application. What you see here is a Raspberry Pi, and I have a proximity sensor hooked up to it, so you can tell if someone walks over to the room, I can give them a custom experience of how they do that. So let me show you it here running, because I have one running here. So when I walk in front of it, you'll see that it'll detect me, I'm here, and it'll start the slideshow. And it'll start rotating through several of the images. And then as I move closer, it'll say, well, I know they're closer, so I'll get denser. And even closer, it'll get more dense. When I move away, good, I'm glad it worked. Those things are it's always nice when they do. And it'll just turn off when I'm not in front of it anymore. So that'd be great. And the nice thing about it is, since it's a universal Windows platform, it runs on those devices as well. So let me hop over and show you the code that I wrote to talk to that sensor. So let me move over to my sensor code here. And so that's a little bit special code there that in the past, if you were running on anything other than Windows 10, you would have had to go write a driver, and you would have to talk to this special bus and add a bunch of support. It was a fairly complex amount of code. But with Windows 10, we now directly support talking to these various different buses. And so here, I'm talking to an I2C bus. And so what I need to do is, in my function here, first thing I need to do is enumerate the devices that are on the bus. Then I will establish a connection, and a lot of this information comes from the device. Got to read the manual. You can try and guess the parameters here, but typically read the manual and get the SDK for it. And then set up a timer that will go and sample that periodically. Now, once I have all those samples, then I can go hook up, how close I was and how fast it changed. And then I can create that behavior. Very straightforward, easy code now that we have support for all these buses in the Windows, Universal Windows platform. Now, once we've kind of set up all these things in the showroom, the most important thing is the presentation. They'll go off, they'll finalize it, they'll do some sketches, and they'll come back with a design. And they got to close the deal. They want the best presentation that they can possibly set up. So we think really the best way to present that is on a large screen TV, because we all watch our home remodeling shows, don't we, right? Everybody watch those? And they're always on our TV. So that's kind of the best way to go present it. So here, I've chosen to show this on an Xbox One running on the TV here that you can show on a TV. And so I'm going to run the application. And again, because it's part of the Universal Windows family, it can run any app that was built to the Universal Windows platform. And so I'm going to go into presentation mode here. And here we've got a sketch of a 3D model. That's the room. And so you can go present that, and they can look around and see the different rooms and whether they like them or not. And sure, it's a little void right now because I'm really not very good at designing. But nice, great experience. But I was thinking, if you want to be the best one out there, you want the best experience for your customers, there's another device in the Windows family that will provide even better experience. Can you join me in welcoming Felicia from the HoloLens team out here to show you this same exact app running on the HoloLens? And so what you'll see here is the same app that we wrote runs on the HoloLens because Windows Holographic is Windows 10. And so here we have the same exact model, and she's able to look at it, walk around it, look at the flooring, see it looks a lot nicer than it did on the Xbox, and kind of just look around this and get just a great experience using the same exact application. Now, of course, we probably would go on and build a more customized experience, something that she could be immersed in and walk through it, and that would be all great. But I want to show this exact same app running to show you that a very simple app can be moved over to the HoloLens just as easy as any app can be moved among any of the device family. Thank you, Felicia. I appreciate it. So what I want to show you is the actual code that we wrote to make that work on the HoloLens versus what we had on the Xbox. So before I jump into that, I want to explain a little bit about how the camera works. In HoloLens, the camera moves all the time. Whenever the person's head moves or tilts or they move around, you must keep up the camera or the object will not look correct. In the past, the camera has been controlled by the developer or the programmer in most cases, but here it's controlled by the end user. And so it's also a stereoscopic camera. You have left and right eye, whereas on the Xbox, it's a flat 2D. So the camera on the Xbox, the 3D model is the same. It's the same exact 3D model, but the camera was a fixed 2D camera that would take it, create an image from the three-dimensional object, and then show that on the screen. On here, we're going to have to keep updating it with the left and right eye and update the parameters. So simply on each update, so this update gets called whenever she moved or looked around or tilted, and I need to go update the left and the right eye, so I'll read those from the HoloLens, and I'll update those parameters in my rendering loop, and then I need to go update the rendering resources and the shaders based on those new camera positions. So this goes and now creates an interactive experience where she can walk around and see and interact with that model. So fairly straightforward for a very simple application. Obviously, for some of the more advanced stuff we saw yesterday, a little bit more of investment in code, but then you get a lot more benefit for the customer. So I've kind of gone through a lot of devices and shown you the same exact app running on all of them. But the goal really being that it was centered around the user. They were able to use that app with the right device. They made sense for the task and the part of the operation that they were doing. And they can provide, this company can provide a great experience for their customers and really could differentiate versus the competition. Thanks. Back to you, Dave.
Great job, Kevin. One device, one app across all the devices. It's really pretty remarkable. Visual Studio 2015 makes it easier not just to develop your apps, but to debug them as well. The improved XAML designer makes it easy to review and adapt your UI for each device. You can jump between phone, desktop, and other views of your same XAML layout inline. The new live visual tree lets you select, inspect, and edit elements in real time in your running app. It's like browser F12 tools for app development. It's so cool. Visual Studio pushes the state-of-the-art in diagnosing performance issues by allowing you to identify performance issues without even leaving the debugger. You can see how long code takes to execute through perf tips. You can visualize your app's CPU and memory utilization through the CPU and memory graphs. All this without having to switch and run a separate profiling tool. Windows 10 makes it simple to distribute a universal Windows app and offers more powerful insights into your app's usage. There's one submission process for all devices. There's one set of certification policies to go through. No other platform makes it this easy to distribute your app to such a broad range of devices. New features from the store let you analyze your usage and monetize your apps. App Insights are integrated right into your apps and dev account, enabling you to answer questions like, how many users are getting stuck in a level of a game? How is a specific feature actually being used? Campaign attribution lets you compare the success of your app marketing strategies and get your data within a few hours so you can adjust your strategy in real time. So that's how the Universal Windows Platform on Windows 10 helps you design, debug, develop, and distribute your app. Those of you that have already bet on the Universal Windows Platform can benefit from all of that in Windows 10. For those of you who don't yet have Universal Windows apps, let's talk about how we're going to help you get your code to the Universal Windows Platform. We all know the best apps are the ones developers have poured their blood, sweat, and code into. The whiteboard sessions working through your app's design. The late nights hunting down and fixing that gnarly bug. The excitement and anticipation of pushing out each flight. It's not just your code, but all that has gone into your code that ultimately makes your app what it is. At Microsoft, we live and breathe developers. We recognize this fundamental truth. Your code is the soul of your app. And that's why we're so passionate about building Universal Windows Platform bridges that let you start with your code, no matter where it was born, and bring it to the Universal Windows Platform and store. The first bridge that we're going to talk about today is how you can bring your web code to Windows 10. There's a new web rendering engine, Microsoft Edge HTML, that's built for the modern web. It powers both the new Microsoft Edge browser that Joe showed yesterday, as well as web content in Universal Windows apps. Microsoft Edge leaves behind all of the Internet Explorer behaviors, all the behaviors specific to Internet Explorer that have been built up in the last 20 years. And it has over 4,200 interoperability improvements to ensure that the web just works. For developers, this means less time fixing up your web apps to work across browsers. Microsoft Edge HTML also features over 45 new web standards, including HTTP2, web audio, and a bunch more that you can see here. This is just a snapshot. We've been doing our Microsoft Edge HTML planning in the open, with new features coming into Windows Insider builds each month. While improving interoperability and adding new features to Edge HTML, we didn't forget to pay attention to performance. On the Jetstream benchmark created by Apple, which simulates complex web applications, Edge HTML is over 1.5 times faster than IE11. Beyond that, it's also ahead of the latest 64-bit browsers. Next, on Google's Octane benchmark, created by Google, Microsoft Edge is over twice as fast as IE11. And again, Microsoft Edge leapfrogs into the lead ahead of the other 64-bit browsers. rest assured that great web performance will continue to be a priority for us. Beyond making the web run great on the browser itself, Windows 10 provides a powerful new path for sites to become apps. With Windows 10, you can reuse your existing website code and create an app that points directly to your URL. You don't need to rewrite your server code into packaged client code. You can access Universal Windows Platform APIs directly from the web code that came down from your server. And you can distribute the app you've made in the Windows Store. This new path is fully integrated into your existing web workflow. You can continue to use the same tools, libraries, and services that you use today. You can continue to deploy to your servers to make updates. Kevin, show us how to make a website into an app.
Great, thanks, Dave. So I have here a website that I've built, and I'm going to show you how I've made it into that hosted web app here. So first I'm going to show you the site running in Microsoft Edge. It's a flight arcade app, flight simulation, kind of cool to play. And so here I'll just go start, and you'll notice here that it's a beautiful looking app, great graphics. It's also got great audio, because audio's got to be there in every game to be cool. But this audio here is actually using that web audio. And as you hear me throttle up and down, it's actually a single audio file that we have that we're using web audio to modulate. But I'm really not very good. My team told me not to fly. But I've got a game controller here, and we've hooked this up to the new gamepad support that we have in Microsoft Edge HTML. And so I'm able here to try and, let's see if I can, I like to fly fast and loose, but not very good. So we'll kill that before I go crashing into the earth. And now there's a couple other features that I wanted to add that really aren't available on the web platform. One is integration with Xbox Live. And so here I'm going to launch the same app with the same site, but hosted inside of an application. So I've already deployed the application here, and when I run it, it logged me into Xbox Live. It had my crash credentials from the machine, and it automatically just logged me right in. The second feature that I wanted to go add is Cortana integration, the ability to launch this application using Cortana. So I use Sublime and to edit, and I also use Git as my repository. So what I'm going to do here is edit the code. I'm going to submit it to Git. It will publish it back up to Git, and then I'll have it automatically deployed to my web server. I'm not going to reinstall the application. I'm just going to rerun it, and automatically it's got all that functionality with no update, no ingestion process, or anything like that. So here, let me uncomment the code, save. Adding Cortana support. Wait for that to go work. Here we go. And now I can go to Cortana and say, Flight Arcade, go to waypoint Alpha Bravo.
Okay, going to Alpha Bravo in Flight Arcade.
And so you can see here that I was able to launch the application using Cortana, go to a certain point that it deep linked inside. I had set that up automatically. And it did also that integration with Xbox Live. And of course, my team set it up so that by doing nothing, I can get an achievement. Everybody wanted that? Everybody gets an achievement doing nothing. So there you go. Very simple, able to go do that and continue in the developer workflow for web developers are typically used to. Back to you, Dave.
Thanks, Kevin. All right, let's shift gears, to use a Googsism. Was anyone here at the PDC in 2003 when we introduced WPF? How about 2000, when we introduced Windows Forms? Still a few hands. Let's go way back. 1992, Win32? All right. Later this year, Windows 10 will provide a bridge for you to the Universal Windows Platform and Store. Apps written to these classic platform technologies will be able to be packaged and deployed with AppX. You'll get the same fast, safe, trusted deployment as apps written to the Universal Windows Platform. You'll be able to distribute these apps via the Windows Store. You'll be able to call even more of the Universal Windows Platform APIs directly from your existing code. Live tiles, notifications, Cortana, and more. Now I'm going to turn it back over to Kevin to show you how to use the Universal Windows Platform APIs from your existing code.
Thanks, Dave. So of course, since I've written nearly all these platforms, I've shown you web, I've shown you Universal Platform. Now I'm going to show you a WPF application. So let me just run it here, just to give you kind of a look at it. It's a very simple application that I've written, but it's basically it's a personal trainer application that allows me to track information about things that I eat, my workouts, my health information, a bunch of different things. And what I want to do here is add two specific features. One is a very simple feature, the ability to just pop a toast. And I want to show you just how simple it is to show it's not a lot of complex work just to call one of the new universal APIs from a WPF application. The second is one of our more complex ones. We've added a feature called App Services. This is the ability for universal applications to provide services to other applications so they can call them and they can basically work together and on different data and different services. So the first thing here is when I hit the launch button, I just want to pop a toast. So it's very simple code. It's 3 lines here. First, you'll notice that I had added some namespaces up here, otherwise it wouldn't compile. These are just the Universal API namespaces that I use. Then for the toast, I get the XML for it, I create a new toast, and then I just say show toast. So let me run this code. And so when I click launch, this will pop what we call an interactive toast. This toast actually allows me to open an application from it. So what I did is I popped this here, and the XML said, open the Microsoft Health application. So I'm going to click on that, and it actually opens this app here. This is a sample app that allows you to gather information from the Microsoft Band. And I've been wearing that for a while, and so it's tracked my heart rate and different things that it tracks. And so it has also an app service that we've implemented. And so what I want to do is be able to call that app service to get all of that information from the last week. The nice thing about app services is I don't need this app running to be able to talk to it. So I'm going to close the application, and then when this calls it, it will just directly connect to the application in the background. So here is, I'm going to add my click handler for that start button that I had in there. And I'm going to pop the service here, the code here, to talk to that service. So the first thing I do is I establish a connection. I do a strong connection here. I want to know that I'm talking specifically to that application. So I have a GUID here and an app service name, and then I just establish a connection. The next thing I want to do is send it a message. So I want to send it a message to get the past week's data. So I send it this message here. I wait for the server. I do it in wait here. I send it asynchronously. And then when it's done, it comes back. I update my user interface with the data that I got from it. So again, very straightforward and not a huge amount of code. So here, I'm going to hit start. It will take a few seconds, not even. And then it talks to that app service in the background and has pulled that data and integrated it in directly into my WPF application. So I've showed you that you're able to do very simple things with a few lines of code, or you can do one of the more complex things, integrated with these app services, a brand new feature with the platform coming in Windows 10. Back to you, Dave.
Thanks, Kevin. Now, let's talk about the bridge we're building to help you take your Android code and get it to Windows. You can reuse the existing Java or C++ code you've written for your Android app. You can continue to work in your existing tools, even using Android Studio to produce the app for Windows. When you make the app for Windows, function calls and even services route to deliver the correct Windows experience. You can update your code to take advantage of key features of the Universal Windows Platform, like live tiles. You can distribute your app through the Windows Store to phones running Windows 10. Let's take a look. Yesterday, you saw how you can start with code you wrote for Android to create an app for Windows that integrates with Windows shell features like keyboard, touch, and navigation. Today, I'd like to show you how, starting with your Android code, you can integrate with some more advanced Windows capabilities. This app, Lose It, empowers people to live healthier lives and achieve their goals through rich experiences and insights about their lifestyle. This version of Lose It, running on a Windows 10 phone, was built starting with the original Android code base. All right, all this talk up on stage, it's like exercise for me. I'm sweating a lot. It's kind of fun. So let me log this exercise. You can see I have stage talk as a regular exercise in addition to running and bicycling. We're supposed to be up here about 45 minutes. We're going to be about that by the time we're done. We go ahead and save. Now we've got Stage Talk logged as an exercise. Now Terry and I, sometimes we're in competition over exercise, so I'm going to share this Stage Talk workout that I did with Terry. This app is using the Windows Share contract instead of the default Android experience. If I were to click into messaging, I'll not actually send it to him, but you can see how it brings up the Windows experience for sharing. This is just one example of how Windows apps that reuse Android code can interact with other Windows apps. Now these apps can also use key universal platform APIs like live tiles. If you look in the upper right on the screen, you can see my start screen is a live tile for the sample app Timber. That's Timber with a B as in Bravo. It occasionally changes state. Timber is another Windows app that was also built starting with an Android code base. With just a few lines of code, it was able to integrate a live tile. Apps can also integrate with Microsoft Cloud Services with minimal effort. Here, Timber is showing me a map of my favorite national park. Maps are one example of cloud services that modern apps expect and use. It was trivial for the developer to invoke Bing Maps in place of Google Maps when running their code on Windows. Part of the bridge we're building for Android code will include a rich SDK for Microsoft services in Java to make it easier for developers reusing Android code to build a successful Windows app. And as far as tooling, I'm not going to show you this right now, but there's a session later on today where you can learn how to reuse your current IDE and workflow to build great Windows apps from your Android code. That was a big step for us, in case that wasn't obvious. Now, let me walk you through the Universal Platform Bridge for your iOS code as well. It lets you import an Xcode project into a Visual Studio solution while sharing the exact same source code files across the two projects. You can work in the familiar, powerful Visual Studio experience to edit, debug, profile, and ultimately build your Windows app. You have full access to the API set the platform provides, including things like Cortana. And you can integrate C and C++ code in with the same project. You're producing a universal Windows app that you can deploy to the Windows Store. Let's check it out. Here we have a directory with the source code files for the MathDream project that Terry showed yesterday. Same exact Objective-C files. In the command line interface, we're going to run a little batch file. And what this batch file does, it runs the code that's going to do the conversion of the Xcode project to the Visual Studio solution. If you watch in the Explorer window over here, a bunch of new files showed up, including the solution file. Double-click on it, we'll bring up Visual Studio. And we've created this MathDream project from the Xcode project. It still has the original Objective-C code from the iOS application, and you can see it in the Visual Studio view. Simple F5, we'll build and run it. And for a simple app like that, that's all it takes. Here's the app running, the same one you saw yesterday. We can add the apples, simple arithmetic application. But now let's take a step and bring this one step further. We know that great Windows apps also want to take advantage of all the compelling, unique Windows features that we've been talking about in the Universal Windows Platform. So let's actually do that. First, we're going to add a couple of files that we've already written into the project. These two files. And then what we're going to do is we're going to make a couple of small modifications to this source code. You're not going to enjoy watching me type source code, so I'm just going to cut and paste this from the popular Notepad application. All right, now when we rebuild this project, it will rebuild it with the changes for the new interactive notifications. It's the same concept that Kevin showed with Band, but now we're going to have an interactive toast added to this particular application. F5 to run it. Now what we've done is if you do a math operation that results in 10, we like the number 10, it brings you this interactive toast down at the bottom right. And what we can do is the compelling feature of unlocking division inside the application so that we can have all 4 basic arithmetic operations in the app. 6 divided by 3 is in fact 2. So that's how you can add unique universal Windows platform capabilities to an existing iOS Objective-C application. All right, thanks for your attention. That was a look. That was all a look at how you can take your universal Windows platform bridges to take the code you have today, no matter where it was born, bring it to Windows. Then you can build experiences only possible on Windows across all our family of devices by taking advantage of unique Windows features like Xbox Live Services, Cortana, interactive notifications, live tiles, adapting and tailoring your UI, inking, sensors, holograms, and much, much more. I'm psyched to see what you all do to change the world using the universal Windows platform. Thank you very much.
Coming this way, David.
There you guys are.
There you go. Great job. That was really good. Really good. Big hand. Those guys cranked it out. That's exactly what you were looking for. Right stuff? Everybody's awake now? All right. The nice thing for us is we get to take the work that Kevin showed you and David showed you, and we bring it to life. We've already started working with developers building solutions on the technology. So you see a slide here of Shazam. Shazam is taking a web experience, turned it into an application. It's a nice mix because it uses C++ code for doing the music recognition, but then it's all web-based experience. We put it into the store. They can deep link, so from within the app itself, you can go in and download music, so it's got links back into the platform itself. And from there, there's actually an opportunity for monetization through a referral program. So the RDO one we saw earlier is also a web-based experience. So we're starting to bring these things to life. I got a couple here just to take from where Kevin was. First one's one of my favorite. I'm a longtime Fitbit user, about 2,500 miles a year. And so here, 2 things that come out of what Kevin was showing you. One, today if you use Fitbit to connect to the PC, you need to use the Bluetooth dongle. So you plug it into the side of the PC, and then when you're working, and you're moving around, that's how you do the Bluetooth connection. Don't need the dongle anymore. Connects automatically. We don't have to use that for the PC. Works just like the phone. The second thing is building from the ground up, taking advantage of the responsive design. In this particular case, you'll notice here's my control panel. This is my dashboard. If I start to slide down, it gets very clean, as I come down. And here, sort of tablet form. If I go a little smaller here, this is phone UI. And John's got it up and running on the phone next to me. And you'll notice, let's see if they can project that, the phone UI looks exactly the same now as what we've done on the desktop. So you have this really great ability to take the app and scale it across all the devices without having to do extra work. Now, the other side of this particular conversation would be up to the Xbox. So if we switch over to the Xbox, I can take that same dashboard.
And here I'm going right into the Xbox. And notice I'm using a pretty radically different way to navigate around this, but I get all the features through that universal app.
I think there's a magic of code here because a couple of your guys have more steps now than I do, which is there's just something wrong on that one as well.
Maybe they're on.
I've been pacing backstage for hours. So here's a good example on the consumer side, Fitbit. We want to thank them for letting us show it. Now, on the other side of the coin, on the commercial side, right, this is an application from Siemens. This is called JT2Go. And if you think about design, this is sort of the designer for physicists. So if you want to build bridges, if you want to build ships, or in this case, if you want to build rocket ships, this is literally the tool set they use. Very high end, has all the physics applied along with the math. Now the cool thing is I have it here on the Surface Pro, right? Can use it with touch and interaction. But same application, if we go back over to the Surface Hub, now we see JT2Go up on the big screen. And here, we can collaborate, work on it together. John can use the smooth inking.
Yep. So this is the actual rocket from Orbital. And you notice you can see pretty amazing stuff like this connection here. Maybe that's a little too close, something like that.
Yeah, and we could work on it together. Let's pen has decided to
Maybe over there?
give up on me. All right.
No.
Well, we could work on it together, but we're going to use your pen for now.
Okay.
It's all real code. That's the challenge. Go ahead.
So one of the great things that we can do in addition to what's happening here is we can bring in, for example, experts. So if Googs and I, who happen to not be rocket scientists, wanted to understand whether we got a problem here, just bring up Skype, have the conversation, and off we go.
And Skype's built in. So take advantage of all the different services with the applications. And so good set of conversations. There's a whole set of partners we're working with on this in ISVs. I wanted to sort of build off of where David and Kevin was and sort of link into one of the conversations we do have on a pretty regular basis. We often get questions. They showed us how to sort of build a universal Windows app from scratch, how to bridge in. Sometimes we'll get the question, if I'm starting from scratch and I want to build an application that runs across all the devices, what's a good way to do that? And so there are multiple plans or ways to do that. Last year, 2 years ago, we showed Unity for the gaming platform. Last year, we took what Kevin had built the day before on day one and used, it was a .NET application. We used Xamarin to bring it over to iOS and Android. So this year, we thought we'd pick up on the web theme. And if we wanted to build a web experience or a web application that runs across all devices, how could we do that?
Yeah. So as you saw earlier today with Kevin's demo, with the flight game, what Shazam and others are doing, we're able to take a web application. Here's a web application, very simple, using modern frameworks. And what we'd like to be able to do is very quickly generate a Windows app. The key to this is a new format from the W3C called a manifest. And I've got the manifest for this particular app sitting over here. And really, it's the simplest thing. It's just a JSON description of where the app's located out on the web, whether you want this thing to be full screen, icons, various things like that. Again, all standardized. We load that into the Windows Store by giving it the URL to the app, and it goes and produces the Windows application, and we saw great examples of Kevin showing that up and running. Now, wouldn't it be cool if you could take this same manifest, this same approach, but also create that same kind of experience, but on, say, iOS or Android or other platforms? So we're pretty excited to announce a new capability today. If you're a web developer, chances are you know JavaScript, and chances are you're probably using Node on the back end. So we've added, and we're announcing a new thing. You're probably using the Node package manager, and if you type npm install-g manifold.manifold.js, that will go download this tool set that I'm about to show. Now, I've already done that, so let me just actually have this work. Here's manifold.js. There's the URL to my app. I'm just going to turn on logging with debug level so you can see what happens. So there it is. It's reached out across the web. It's picked up that manifest, and it's using it to go generate a bunch of applications. In fact, let's go see what it's done. So we're going to go down into the Shifter application, and I'm just going to launch Explorer here so you can kind of see what's going on. And notice, it's now automatically generated apps for Android, for Chrome, for Cordova, Firefox, iOS, web, you name it. These are now ready to go as apps. So let's dig into the Android example. I'm going to launch this. That's going to bring up Android Studio. And it's going to use a very powerful piece of open source technology, Cordova, so that it can use that set of web technologies as an Android application. And we can see that coming up now. So here's our Android application up and running. We could go through this, look at all the Java and so on. Now, I'm just going to hit run, and that would go off and compile it. But Steve, you have the apps up here and running.
Let me bring that back up. So I have two devices here. I have an Android device and I have an iOS device. And we have that same Shifter app basically built and running on both of the platforms, straight from what John did. Really easy to work with. And of course, we could have some fun picking our favorite frameworks here if we'd like.
Yeah. Now this might almost seem like magic, but it's amazing how many partners we're working with that have actually started this way.
Yeah, in fact, the conversations we talked about Salesforce before, that's exactly how they operate. They basically do their dynamic content up on the web with HTML5 and JavaScript, then do native code locally. They use Cordova, and that's how we started the project together in terms of building the Windows 10 application.
Yeah. So what I'm doing here is I'm closing down everything, and I wanted to talk for a second about one of the challenges when you start building apps this way. I mean, it's fantastic to be able to generate these apps and put them out there, but we lose one of the most powerful features of the web, which is the fantastic debugging capabilities that are built into the browser. So we've got a cool additional project that we wanted to announce today called Vorlon. Now what Vorlon does is it's a package that you add to your web app, and it reaches out across the web to a Vorlon server running in Node.js. And as you can see, this is connected to our Android and iPhone app. I'm going to go start up the Windows version of the app. And as you can see, it's now popped that one up. I can select it. Not only that, I can reach out anywhere. This app could be running in Australia. We would see that thing pop up. I can identify it just to make sure that I'm thinking about the right one, so we have the ability to interact with it. I can look around at the DOM. I have a lot of capabilities here. In fact, I can go in, do things like write to the console, all that stuff. I'm just going to do the simplest thing. I'm just going to call a function that would be equivalent to if I clicked that I liked one of these frameworks, and I'm just running that remotely. Notice I reached out across the web, injected that into a running Windows application, running iPhone application, all nice new ways to develop using the web technologies.
Slick stuff, John. Then the other one then is obviously the ASM work. Let's give John a hand for that and the team.
Yeah, so look, the whole web space is just, the level of innovation going on there is incredible. And we're seeing stuff like the Babylon work that we announced last time. Another project that we wanted to announce today is the ASM.js project, which gives us a way to write down in JavaScript a subset of that that can be easily compiled and provide high performance. So again, we're very supportive of both this cross-platform way to do things, but also bringing in open source into the whole approach.
Right. Thank you, John. And I think, in terms of open sourcing and sharing code, we've done a lot of work with GitHub. John says all the projects here will be up on GitHub. One of the things they've done is they've worked really well with us on students, a bunch of areas. I'm happy today to announce we now have GitHub Enterprise for Azure up and running. That means if you're behind the firewall in a commercial entity, you can use your Active Directory for sharing code. We can scale to all the developers out there and work together on Azure. So again, just trying to contribute into the community from a bunch of different areas, make sure we can share code and projects and work together. Now, I'm not going to use switching gears because that's been overused. Why don't we go Python-esque with a noun for something completely different? Yeah. We'll go that way. One of the conversations that I thought Scott did a good job on yesterday was around data and scaling out data, security for data, data lake. There was just a whole bunch of parts to that. And we end up with a lot of conversations where people want to talk about data as a platform. Data as a platform is incredibly interesting, but you have to be able to do something with it. The ability to understand and act on data and bring it to life, that's where the magic is in a lot of the cases. There's nobody better to talk about that than our own Joseph Sarash, who leads the machine learning group, an expert in the area. So I thought we'd have him come out and sort of give us a walk around the park, in this case, building on top of the data with machine learning, real-time analytics. Let's see where Joseph's coming out from.
All right.
There he is. Joseph, welcome to the stage.
Thank you,
How are
Steve.
you? Have some fun. We'll be back in a little while.
Yes, thanks.
Great.
Software is eating the world. Mark Andreessen said that about 4 years ago. But today, the cloud is eating software. Software is being delivered as services in the cloud, and most pieces of software are connected to the cloud. Now, the cloud's not only eating software, but it is eating data. And when the cloud digests software and digests data, it can produce intelligence. Let me tell you what I mean. For human history, most of human history, the world was analog. Once upon a time, in the 1980s, analog data dominated. Digital data was just being born. And come the 90s, you have the internet, you have client-server computing, you have digital music, you have DVDs. And the digital data exploded. But with the internet, one thing very interesting happened. Data started to have an IP address. It became connected data. It lived on data centers, on the cloud, PCs and devices, but it was starting to have an IP address. And fast forward to today, digital data dominates. Analog data is going down, and about half of all digital data is connected. It lives in the cloud. It's flowing in from mobile devices that are connected. The Internet of Things is just starting to emerge. And there are about 10 zettabytes of it. That is 10 million petabytes. What about the future? Look at 2020. In 2020, we are going to have 50 zettabytes, 50 million petabytes of data. The vast majority of that is in the cloud and flowing in from connected devices. Analog has gone down almost to zero. The cloud is where the data lives. That's where the planet's data, intelligence, and information resides. And that has profound implications for developers. So the best way, so when I talk to developers about these, we tend to have about 4 conversations. So developers want to look at historical data and look at it retrospectively. It's big data, you want to analyze it, you want to report on it. But then there is real-time data, data that is flowing in over the wire. And developers also want to analyze that as it is flowing through the wire and get insights from it. Developers also want to look at historical data, learn patterns from it, and predict the future. And they want to bring all of this together into intelligent SaaS apps. To bring this to life, let me tell you a story. My story is about the connected cow. Yes, there is such a thing as connected cows. It has all the buzzwords of today, the Internet of Things, analytics, the cloud. It's perhaps the sexiest story in the cloud. But it's also about human ingenuity and how this new technology is revolutionizing even some of the world's oldest industries, such as dairy farming. So these are the connected cows that I'm talking about. Look at those pedometers on their legs. They're connected to Wi-Fi. I have one of those in my hands, the cow pedometer. It counts the steps of every cow in a dairy farm and sends that data to a service on Microsoft Azure. It is Fujitsu's Gyuho, which means cow step, service in the cloud. So do cows need to take 10,000 steps a day too? But before I give you the answer, let me tell you about the modern dairy farm. You know, these days, every company is a data company, even the ones you least expect. A dairy farm has all the constraints of a modern business. It has a fixed herd, it has a pasture, and labor, which often is very expensive. And their output is milk and beef, and they have to optimize that output under all of these constraints. So what can a farmer do? It turns out he has 2 controls. He can detect health issues in cattle early and prevent loss. He can also improve cattle production by accurate detection of estrus. Now, if you remember high school biology, estrus is when an animal is ready to mate and goes into heat, when the time is right, when the magic is ready to happen, so to speak. But how could you detect estrus in hundreds of cows in a dairy farm? Well, before I tell you, let me tell you about the importance of doing this. These days, with artificial insemination, the probability of conception is pretty good, about 70%. But detection of estrus has been done by age-old methods. It's just really close observation. And in the best of cases, you get about a 55% accuracy. And then the pregnancy rate is about 39%. But if you could move that detection rate up to 95%, look what happens. You get a pregnancy rate of about 67%, which is a big improvement. It's very material for the dairy farmer. But this is hard. Estrus lasts only 12 to 18 hours every 21 days, and it's variable. And it occurs, like many of these things, mostly between 10 p.m. and 8 a.m., when the farmer is taking his hard-earned rest. So how can farmers tell when the time is right for hundreds of cows? Could technology help? Could you develop a heat map of the dairy, so to speak? Well, that's a question that a farmer in Japan asked Fujitsu, our partner. Fujitsu engineers consulted some researchers and came up with a very ingenious system, something that was indeed 95% accurate for the detection of estrus. It's literally the hottest system for detecting heat. Now, this is that service. Data from the pedometers that I showed you from the cows are sent over the wire to a service on the cloud on Microsoft Azure, where it analyzes all of that data, and from the footsteps of cows, detects when the animal goes into heat and sends alerts on the farmer's phone, so the farmer knows which cow went into heat and exactly when. Well, turns out there's a very simple secret to detecting when an animal goes into estrus. Let me explain that to you with a graph. The x-axis is time of night on this graph. Y-axis is the number of steps a cow is taking. So this is a cow on a normal night, sleeping sometimes. Let's see what happens when the animal goes into heat. Yes, the number of steps she takes goes up. When the animal goes into heat, she starts walking around furiously. And that turns out to be about 95% accurate for the detection of estrus. And the optimum time for artificial insemination for maximum conception rate is 16 hours from that. And that's when AI meets AI, artificial insemination, that is. Now, Fujitsu researchers found something else that was very amazing. There was a window around that optimum. If in the first 4 hours of that window, if you performed AI, you would get a female. And the next 4 hours, you would get a male. So the farmer now had an amazing control at his disposal. He could choose the gender of the calf based on the needs of his dairy farm. Not only that, Fujitsu found that by analyzing the step patterns of cows, they could detect about 8 different diseases. And remember that 5% false positive rate, 95% accurate, 5% false positive? Even some of that turns out to be very important because some of it's when the cow jumps over the fence and skips the farm. Well, it's an amazing application. But it's an application that today every one of you could build in a few days with the platform services that's available on Azure. And you can scale that out globally, distribute it, and this would never have been possible before. So that's the power of intelligent apps that live on the cloud. And now let's look at the power of real-time analytics. Data is always moving these days. It's constantly in motion. Connected data coming from sensors, from websites, from apps in the cloud, from social apps, it's streaming over the wire. Now, developers want to easily process this data and get insights in real time. So now let's take a look at an example of a solution that does that on Azure. So with me is Coram, who's going to help me through a demo. We're going to create an app that's going to be a fun, engaging demo, and you are going to actually help us create data in motion. Okay? When we started this, we wanted to build a fun and intelligent application, something that would capture the attention of people worldwide. So we went to the machine learning gallery, and today we have an exciting collection of intelligent APIs on that machine learning gallery. It's gallery.azureml.net. All of you can go there. And yesterday afternoon, Harry Shum, the head of MSR, announced Project Oxford to bring some of the amazing intelligent APIs that has been created by Microsoft Research and Bing to developers like yourself. There are face APIs, there are image analysis APIs, there are speech APIs. So we took the face API. It's a really fun API that allows you to submit a picture. It detects the faces in that, and it tells you an estimate of their age and gender. So the URL for this demo is howold.net. Now, I'd like everyone here actually take a minute and go to this URL, especially everyone watching online. Please navigate to the site and take a look. So let's take a couple of pictures. Let's look at that happy family. Let's submit that. And you will see it identified the faces in the image, the grandparents, the parents, the children. It got that, it looks like it got pretty accurate. So let's try another picture. Let's take, say, Da Vinci's Mona Lisa, a painting. And so we're using the Bing Search API to search Bing, get the images from online, and hopefully we can bring, Mona Lisa's image up. So let's submit that photo, and she is 23. Surprisingly, when that model posed for Leonardo, she was actually about 23. So now let's all try your pictures. Take a picture from your mobile phone, from a PC, especially if you're watching online. Feel free to take a selfie and send it as well. Let's see how it performs. So Coram, maybe you can take one of our pictures from the desktop. So that's my family picture, just uploaded it. So it's analyzing that. So we can actually see how it's doing on our dashboard as well. Yeah, that upload is taking a little while, Coram. So let's go look at the dashboard and see what people are doing online. It's amazing. This is the Power BI dashboard. John actually showed some of it earlier. People now from all over the world seem to be coming to howold.net, and that map shows the distribution of people. So what's different about this dashboard, by the way, it's pretty amazing that you're seeing real-time flowing data being analyzed. And you see that graph that just spiked up? That's all of you bringing data in motion. Now let's peek behind the curtain a little bit and see how we built this streaming analytics and the dashboard. So the data from the howold.net website is captured as a JSON file. It looks at the face data, the age data, looks at the browser, it looks at the location from which the IP address is coming, a collection of things. That JSON is sent to Azure Event Hubs. Azure Event Hubs is a fully managed service on the cloud to ingest data at millions of events per second. And then we use Azure Streaming Analytics. Azure Streaming Analytics is a fully managed service for complex event processing. It lets you analyze streaming data, put complex queries in it, and get aggregates from that. And then we use those aggregates and display it in a dashboard. So now let's take an example. Let's take that dashboard that is there, that trending graph. So that trending graph shows two lines. You have the blue line showing the count of females in the faces submitted, in the pictures. The magenta is the number of males. And all developers here, if you have tried to construct a trending graph like this over streaming data, I mean, you know how hard it is. It takes hundreds of lines of code, if not more, to set something like this up. Let's now go to Streaming Analytics, Azure Stream Analytics query, and show you how simple it is. So Azure Stream Analytics makes it really simple to configure such analytics using just about 8 lines of SQL-like code. It's a select statement. It's selecting the system's timestamp as out time, the face.gender as gender, and the count of gender from the streaming input, and then aggregating it over a window over a 10-second interval, right? And that's all there is to it. And that's the data that is now being displayed in the Power BI dashboard. So this is the magic of fully managed services like Azure Stream Analytics in the cloud and Power BI. It lets you analyze real-time flowing data and embed intelligence around that into your applications. So now let's go from understanding the present to predicting the future. So if we switch to slides. So in Feb of this year, we launched a powerful service called Azure Machine Learning. It allows you to learn patterns from historical data and predict the future, and create APIs in the cloud that can be easily hooked up into any application. Now, for example, Ziosk is using Azure Machine Learning to produce recommendations on Ziosk tablets on Chili's restaurants. We have eSmart Systems of Norway using Azure Machine Learning to actually predict the energy usage in the future and control energy demand. The Microsoft Band uses Azure Machine Learning for recommendations. We have companies, more traditional companies such as Gaffey Healthcare, using Azure Machine Learning to estimate when an insurance claim will be paid so they know how to act on that particular claim. It's a very powerful service. So the best way for me to bring this to life is to tell you another story. For those of you who are watching this from outside the US, there is an annual sports event here called March Madness. It refers to the NCAA Men's Division I basketball tournament. So it's played each spring with 68 collegiate teams to determine the national championship. And for Americans, we find it as a time to gamble. We try to predict who will make it to the final 4 teams, and ultimately, who will win it all. It seems that everyone has a prediction for the winners. Our President Obama, our CEO Satya Nadella, and Satya's predictions got a lot of press because it seemed to be extremely accurate. And now to be fair, Satya had help. Satya had data scientists and people who knew basketball to help him make his predictions. But I want to tell you the story of Adam Garland. Adam is a developer in our Microsoft Office group. Now, unlike Satya, Bing, and Google, Adam didn't have any experience using machine learning. He's just a developer like you and me. And we had a hackathon going to predict March Madness using Azure Machine Learning. Adam thought it would be a great way for him to learn machine learning. So he came to the tool, he played around with the data, and within a few hours, he was able to create a model to predict who will win in a basketball match. And then after a few days, he got to be really good. And not only Adam, but many of the people who participated in that competition ended up predicting much better than the automated algorithms Google used and Bing used, and was pretty competitive. So these Azure ML tools are very easy to use for developers. So I thought it might be actually fun to replicate what Adam did, to show you how Adam built that app right in front of you, and actually publish an API live, and show you a real demo calling it with a basketball match. So let's see how easy it is to create an experiment. To predict the outcome of a match, whether team 1 will win over team 2, you typically need something called a binary classifier. There are experiments in the Azure ML gallery. So let's take this particular one. This is an experiment you'll find in gallery.azureml.net. So we just brought it to the studio. And this experiment is a workflow. It's actually really simple. So it reads and cleans the data. You split the data into training and test data. So you train a model with that training data, and then you score the test data that you didn't provide to the model and see how well it did. Okay? So let's actually run this and see how it performs. So we're going to now connect the March Madness data set. Okay, so to just get Adam's experiment, you take off the data from the sample experiment, bring the March Madness data set, and now we are actually going to run it. So that experiment is running. And while that's happening, let's look at the data. So you'll see this is data about 12 years of matches. We have the seeds for each teams. And the final column there, team 1 wins true or false, is what we are trying to predict. So let's go back and see how well the model ran. So let's look at the performance. So that graph actually shows what's called an ROC curve. But the most interesting number is the accuracy. So you'll see that simple model performed at the accuracy of 66%. Not bad for a minute or so of work. Okay? You just put in new data into that existing sample experiment and ran it. So now let's see what Adam did. Adam did a couple of things. Adam brought in an algorithm called two-class decision jungle. That's one of the algorithms in Azure Machine Learning. He used something called sweep parameters to sweep over the parameters of that machine learning model and find the best one. He also found that bringing in team performance data would be very, very helpful. So he took the historical data, married it with team stats, and then let's look at that data. When you look at it, you will find that he brought in data such as the field goals made, rebounds. He even found, for example, that team performance from away games was actually a really important predictor of performance, of match performance. So let's see how that model ran. So you'll see the performance went up dramatically. It's just about 74% accurate. And now that we have a model in Azure Machine Learning, we can now create an API with it, a cloud-hosted API. Let's do that now. To do that, we create a scoring experiment. And this is a workflow that will run inside of a web service call. And here's the magic. It automatically identifies what the predictive model is, identifies the web service input and web service output, and we are now ready to publish this as an API. We can run it, and when you publish it, you will get an API that is live in the cloud. So let's see that API now. Well, there. This is a page you get when you run and publish it. You see that API key at the top? That's the API key you will use in your REST call. We can test this. We can test this API live in the cloud. So now let's take that historic match between Duke and Wisconsin that just happened and see what the API predicts. So there you go. The API predicts Duke will win over Wisconsin with a probability of 63.2%. And that's exactly what happened. Now, you can predict the future and build this intelligence into cloud apps. It's very simple. You have C# code, you have Python code. Those are things that you can use to just call that API. So now, let me move from the demonstration to something else that's pretty exciting, about the language of data. Now, machine learning is a field of advanced statistics. And over the last 20 years, a revolution has happened here with the development of open source R. Statisticians all over the world have now started contributing their latest innovation and research as packages in R. If there is one language that is truly about data, something that puts the power of data at the fingertips of every developer, it is R. In IEEE Spectrum's rankings of programming language popularity in 2014, R placed 9th after Ruby. That's just an amazing feat for a domain-specific language. So if there's a single language that you choose to learn today to tap into the power of that cloud, let it be R. Now, and that's why Microsoft acquired Revolution Analytics, the company that made R scale to big data and brought open source R to the enterprise, making it enterprise grade. For example, American Century Investments, one of the largest mutual fund companies in the world, uses it to build their quantitative investment platform. DataSong, a local company, a big data marketing company in San Francisco, uses it along with Hadoop for their marketing performance management and attribution platform. Now, to bring the story of R and big data to life, let me tell you another story. You know, we are all big data. There are billions of letters of genomic data in every one of our cells. It turns out that each human genome is about 2 gigabytes of information. And with the power of R, we can analyze all of this data. And when we plot this set of information against the general population, we can actually see some incredible things about ourselves. So the first human genome was sequenced in the year 2000. It cost about $200 million and over 10 years of work. You know, since then, the cost of mapping the genome have come down much faster than Moore's law. It's about $1,000 to get your entire genome, and you can get the most important parts for about $100. And this is driving an untold revolution. In the future, when you go to a doctor, the first thing that they will do will be to map your genome to understand your disease risks. This will let them treat you based upon your individual genome, personalized medicine. You will even know the risks you should anticipate in the future and change your lifestyle because of it. So let's show that to you with a demo. Joining me is Mario, who was at Revolution Analytics. So genomes are analyzed using the language of R. It has one of the richest libraries for analyzing genomic data. 1,000 people worldwide have contributed their genome to scientific research. It is public data called the 1,000 genomes data set. It's about 2 gigabytes of data per person. And we're going to analyze all of that data and see their disease risks. And Mario is going to actually walk through the demo. Now, it's going to take only a little bit of code, but it's a tremendous amount of computation. So it really needs big Hadoop clusters. So if we could show the Hadoop clusters that we are actually showing, the slides, we're going to use about 8 HD Insight clusters in 4 Azure data centers. 2 in the US, 1 in Europe, and 1 in Southeast Asia, for a total of about 1,600 cores in the calculation. By the way, they are Linux clusters. We are actually running Revolution R on them, and Revolution R is going to coordinate the computation across those 1,600 cores in all of these regions across the world. We're actually going to take computation to where the data resides when we do that global computation. So now let's see the code. So only a few lines of R code. This is the code that's actually used to analyze the genomic data. It leverages some extremely powerful functions in an R package called bioconductor. And let's also see the code that coordinates the computation. So this is the piece of the code that coordinates computation on HD Insight clusters across 8 clusters across 4 data centers. Let's kick that run off, Mario. And let's see what it produces. It produces a heat map. This is a heat map of disease risks. Each row is an individual. We have fictitious names on the right, but each column is a disease. So let's take, for example, the second row from the top, Claire Hickman. Claire Hickman has a high risk of ulcerative colitis. And let's take, say, the third from the bottom, Sophie Albrecht. Well, it turns out Sophie has a high risk of multiple sclerosis. By the way, this heat map is an amazing visualization produced by a package called Shiny in R, and it lets you visualize things and zoom into these things. It's very, very powerful as well. So now you've seen the disease risk of the population we analyzed on the Hadoop cluster, and almost happens in a few minutes, and it's pretty amazing, chunking through all of that data. Now, but what if we could take that R code, publish that as a web service API? So you saw me publish a web service API with Azure Machine Learning earlier. What if I could do the same and create an API that lets you submit data and see your disease risks? So let's see the scoring experiment. This is a scoring experiment in Azure ML. See that execute R script? That's where we can actually copy the R code and publish that as an API. So let's do that now. So Mario is going to copy some of the R code for scoring a person's genomic data, put that into the execute R script, and run that experiment. By the way, as it's running, execute R script shows you how easy it is to operationalize R. Any R code can be published as an API in the cloud. And Azure Machine Learning lets you do the same thing even with Python. It is the simplest, easiest way to operationalize your analytics code as APIs in the cloud. So now let's publish the web service, and let's get that API in the cloud. Here, that's the API page. You got the key. There's even sample code to call that API. But to test this, we actually created there's a sample code. If you click on it, you'll see C#, Python, and R code are automatically generated. So now, to call this API and show you the results, we created a mobile app. I'll tell you about that in a minute. Now, early in April, I sent a sample of my saliva to 23andme.com to sequence my genome. Last Friday, I got the results from that. And so for the first time, I was able to analyze my DNA and see my future. So let's do that now. So let's take the mobile app. Can you all see the mobile app? So I'm going to log into 23andMe, get the data from that website. It's uploading the genomic profile. So you will see a graph that shows the risks. So the blue bar is the population risk, and red is mine. So you'll see that I have low risk for gallstones, low risk for asthma, certainly low risk for breast cancer. But let's look here at the top. Look at that very top line. That red bar shows 0.36. I have about 2.5 times the population risk for prostate cancer. And I just discovered that. That's my future predicted from my genomic data, R, and big data analysis. That's the power of big data and advanced analytics. So if we switch back to the slide, big data and advanced analytics can change lives. My next story is about the connected grid. For a century, the management of power has been by analog systems. Just like the media we were consuming was analog. But now utilities are discovering the power of big data, analytics, and the cloud. And the hero of this story is a small startup from Norway, born in a small town of 30,000 people, and they're reinventing the future of energy management. And they're going global with it. They're reinventing the grid with the cloud, creating great efficiencies through data and advanced analytics. To tell you that story, let me welcome Eric Osberg, the head of development of eSmart Systems, to the stage. Eric? Welcome.
Thank you, Joseph. So let me tell you about eSmart Systems. We accelerate energy systems, we optimize energy investments, and we minimize carbon footprints through better, faster energy decisions. Like many of you, we are in the business of disruption. We're taking an industry that has been operating in the same way for over 100 years, and we use technology to radically rethink the way we approach it. Our disruption is directed at the business of energy, and we started with a pilot project in Norway 2 years ago. So when we started, our goals were to reduce power grid investments by increasing the utilization factor of the existing grid capacity. We needed detailed predictions of load and power generation, and we needed to take advantage of IoT and big data, since smart meters and sensors are a prerequisite for our predictive analytics. So the big question was, how were we going to go off and do this? Are we going to spend millions of dollars and thousands of person-hours in data centers? For us, this was an incredibly easy decision. We leveraged Azure from the very beginning. And what makes this so amazing is that we made this journey of changing the business of energy without acquiring a single server. So here's a look at the eSmart Connected Grid application. All the houses that you see here are equipped with smart meters and sensors, and we use machine learning to identify potential congestions in the power grid. We control consumer flexibility to avoid substation overloads. And we use both short-term and long-term predictions to control heated floors and water heating through home automation. eSmart and Azure Machine Learning use real data to learn for each specific area. And we take this information and we make it available on your phones with consumer apps managed by Azure. Every part of the power grid is unique. There is no system today that is able to adapt to this uniqueness. eSmart Connected Grid and Azure ML totally changed this reality. This is truly revolutionary. So we started 2.5 years ago with no employees, no revenue. By the end of this year, we'll be over 40 employees and over 50 million Norwegian kroners in revenue. I couldn't be happier to be partnering with Microsoft and Azure. And I want to say a big thank you to Joseph for having us here today.
Thank you, Eric. It's an amazing story.
Thank you.
The cloud amplifies startups such as eSmart Systems. It gives them the power to go global. It gives them the power to build applications that revolutionize entire industries in a very short period of time. In the future, all of the planet's power generation, power grids, and power consumption will be optimized with real-time data and data analytics. And so with the power of the cloud, even really small companies like eSmart Systems are able to make that dream come true at a speed that no one else can. That agility, by the way, that agility is a hallmark of the cloud, and that's its magic. You know, the cloud turns hardware into software, software into services, fully managed services, and data into intelligence. It makes you smart, and it lets you free. Thank you.
Nice job, man.
I don't think anybody does a better job of the notion of data as a platform and bringing intelligence to data than Joseph. Great storyteller, great at really, really bringing this to life. So I think we're on our final run. We wanted to sort of bridge from Joseph and pick up on where we were a few minutes ago. So last year, when we were talking about the web, we were talking about the Babylon JS project. John mentioned that earlier. And one of the things we had done is we actually took a web experience, used Babylon JS, hooked it up so we could do virtual reality with it, took advantage of Oculus Rift at the time. This time we've been working further on Babylon, connecting it into the data side, trying to make it more intelligent. So in the city of Pompeii, the government has been using drones to fly around and map the city. And I'm going to fly around using what they've created from that on the web and let John tell you about it.
So in partnership with the Italian government, we took these drones that were flying around, about 50 hours of drone time, and we took over 30,000 pictures, high-res images of Pompeii. And then the very interesting thing is we moved that information up into the cloud where we used Azure and machine learning algorithms to go and generate the 3D mesh that you're seeing in front of you. Now, the thing that's pretty incredible about this is you're actually looking at an image which is about close to 1 trillion pixels. And as Steve's able to do, you can wander around in this thing, you can see any aspect of it. But I think this really illustrates the power of when we can take great innovation in the client, couple it with the machine learning, the big data in the cloud, and bring experiences to every platform that we wouldn't have been able to do before.
Yeah, flew us around. I ended up in the Basilica. So this is a good bridge and transition. A couple things here, which is obviously the cloud side. I also have a machine up here, a laptop with 2 graphics cards, 2 GPUs. And one of the things I want to bridge into is gaming, DirectX 12. One of the things that DirectX 12 allows us to do is actually take advantage of multiple GPUs, so I can have some client-side assist here. And then on the gaming side, look, like music, gaming's an area that I'm pretty sure everyone in the audience has some connection to one way or another. There's lots of conversations around gaming, from the mobile side to the Xbox and others. The real thing there is when you think about sort of high-end graphics in gaming, it's not actually the Xbox or any of the consoles, it's actually back to the PC. And so if I can do that with a 2 graphics card system, we brought along just for fun a box that has 4 graphics cards. Digital Storm lent it to us. It's the very highest end on the hardware side. And then we asked our friends at Square Enix to take the work they do, which is a mixture of science and really the computation side and graphics quality and art, and bring those together and show us a little bit about what you can do with DX12, with Windows 10, and sort of where this whole technology area is going. So first off, I'm going to have their chief technologist sort of give us a little introduction. Let's go ahead and run the video.
皆さんこんにちは。ファイナルファンタジー15を開発するスクエアエニックス PD2 の田畑です。私たちのチームは常に最高峰のプリレンダリング CG とリアルタイム CG を追求しています。今回マイクロソフトと NVIDIA の協力を得て最先端のソフトとハードを駆使した技術デモを制作しました。ビルド2015で公開できるデモはまだ少しですが、このデモはこれからさまざまな取り組みで進化していきます。では最新のデモをご覧ください。どうぞ。
どうもありがとう。So Square Enix has built Final Fantasy, over 100 million copies sold. This is an art and science technology demonstration they put together. What you saw was DX11. What I'm going to do now is run through similar scene in DX12. Now you might assume looking at that that's also a video, but the truth is that's in-game DX12. So what we're gonna do now is I'm gonna go between manual and automatic so I can shift back and forth, and when you see the word manual up there, I'm gonna drive, so let's let this go through auto, and then I'll change the lighting, and you can see this real time. So as it pauses here, I can take over, so now I can scroll around, I can look down, I can change the lighting effects as they come through. I can move on to the next scene. Again, let it run in auto. And now I'm going to take it and drive around. Again, I can adjust the lighting. And we can keep going through in this way. Let me bring the shadows in, take them out. All right, let's keep going through. I'm going to pass through this one and go on to the next one. And we'll see as we get closer, we'll look at the skin tone.
Now, the thing that's really incredible about what you're seeing is just the density of data that's involved in this. Each of these scenes is over 63 million polygons per scene. That's about 6 to 12 times more than we could do with DX11. Just to give you an idea on the textures that you're seeing here, those are 8K by 8K textures, again, significantly more than we're able to do. I think where it gets really interesting, though, is look at the hair. Every piece of hair that you're seeing is actually being rendered as a polygon. This isn't surface map stuff. And as those polygons are running through the pipeline, they're running over 50 different shaders to go through this and to generate that level of clarity on this. I think it's an incredible example of just how far people are pushing the limits of big data and technology, bringing it together, and really building experiences that would be hard to build almost any other way.
And so our thanks to the folks at Square Enix for letting us to show this off and for building it. Incredible piece of technology and art put together. Now, that's sort of the high-end, incredibly fun. Let's give those guys a hand. Graphic-intensive side of gaming. And now for something completely different. If you go to the other end of gaming, one of the acquisitions we made earlier in the year was Minecraft. And Minecraft is a community game. Lots of people like to work on it, mod on it. It's a place we get a lot of feedback to not change the modding side of it, to not change the community. So what we wanted to do was actually contribute to the community. So what we want to do today is announce the availability of a modding toolkit for Visual Studio. I'm going to pass on this slide and come back to it since I paused along. And so I want to invite Aiden Brady. It's a junior out of Atlanta. He's actually one of the top modders in the US. And Brianna Roberts from our team, they're much better equipped to talk about this and demonstrate it than we are. So I'm going to have them come on out. And why don't you guys show us what's going on with Visual Studio.
All right. Hi, everyone. My name is Brianna Roberts. I'm thrilled to be here today. I'm a senior content developer in Microsoft Learning Experiences academic team. We sit within the Developer Experiences organization led by Googs. So why am I here today? Well, I happen to think I have the best job. I get to create awesome content to get students excited about computer science and computer programming. You may be asking yourself, what's hot with kids these days? And the answer is Minecraft. It is one of the newest ways to engage students and teach them about coding using mods like the ones we're going to demo today. Minecraft is an awesome education tool. It's being used in over 5,000 schools, libraries, and after-school programs. All right, without further ado, I want to introduce Aiden Brady. He's a high school student out of Atlanta, Georgia, and let me just throw this out there, but he's a big deal in the Minecraft modding community. His very first mod, Mechanism, has taken off. It's huge. So Aiden, will you tell us a little bit more about yourself and your love for Minecraft?
Sure. My name is Aiden Brady. I'm 17 years old and a junior in high school. I started programming in Python when I was 10, but moved on to Java when I was 12, which I've kind of focused on ever since. A friend introduced me to Minecraft in 2011, and it was kind of the perfect fit for me because I already knew the language and I just loved the creative potential that the game had. I hope to later on get a computer engineering degree and maybe an MBA too, to do what I love, which is maybe to work for a company as awesome as Microsoft.
You're well on your way. Well, I don't know if everyone in the audience has played Minecraft. We have, maybe their kids have. can you tell them what a mod is?
Sure. A Minecraft mod is basically an extension of the Minecraft game. It can add new content, and if you're familiar with the game, it's things like new blocks, new items, but in our case, we're just going to focus on one new block, which is kind of exciting.
As Googs mentioned, Microsoft recently acquired Minecraft, and we're so excited about it, and we really committed to continuing this vibrant community of gamers that we have out there. So what we're going to do today is show off some Minecraft modding using Java in Visual Studio.
Yes, and this tool is fantastic. I recently switched from using Eclipse as my primary modding development tool, and honestly, it's the perfect transition. It's easy, it's intuitive. I love it. I mean, I feel right at home. And right here, you can see on the new project dialog, we have a few little templates here, and I love this. These are Minecraft Forge mod templates, so by clicking this right here, we're able to make a new Minecraft mod just like that and get started. And there's also one that's near and dear to my heart right here, which is the mechanism mod sample, so you can mess around with what I've done.
This is awesome for all these Java developers, that they can just both play and change the game that they love, all within our IDE. Now, if you're familiar with Visual Studio, then you're familiar with IntelliSense. We are going to show off some of the key features of IntelliSense that really bring this modding to life for these developers. I want to make sure I throw it out there that this is not a replacement for Eclipse. This is an add-in that's been built so students just like Aiden who want to build and create can do so in Visual Studio. We're going to get into the code just a little bit. You've seen this with other languages. Now you'll see it with Java. So as I hover over a keyword, I get the quick info, which displays the complete declaration of the code that I'm looking at. Now, as I type a word, and I'll type that period, a valid list of members appears. All I have to do is hit tab. It'll add that selected line into my code. Aiden, do you want to tell us about parameters?
Sure. Parameter info here gives you information about the name, number, and types of parameters required by a method. And in this case, you can see we have a parameter listed in bold. This is the next parameter required by the series of parameters of this method. And it's fantastic for new developers. I mean, I wish I had this when I got started because,
yeah, I can't even imagine learning to program with this kind of help. This is awesome.
All right, but on that note, I say enough coding, and let's play something here.
Okay, so what do we have now?
All right, now this is a little project that I've been working on. If we open this up here, you see we're going to run this directly through Visual Studio. And as this is loading, I just want to say, when you think about Minecraft, you think about the game, you know, like I already mentioned, the creative potential that it has. And that's why I got into the game in the first place. You know, you're open in this world, and you can do whatever you want, build whatever you want. It's so cool. But, okay, getting in here, I'll open up our little test world. And in here, I'm going to open up my inventory, and you see the normal Minecraft TNT block right here.
Sure.
But we have a fancy TNT block here that's going to do a little bit more damage than what you might be used to. So here, I'll place a few of these down.
It's perfect because I happen to have this trigger over here. So I think it's going to help us with this explosion. It's a little smaller than when I ordered it online. Okay, I'm going to hold this.
All right.
You ready? Go.
Whoa!
That was awesome. This extension is available now. Make sure you go check it out. We cannot wait to see what you build with it.
Thank you so much. What do you guys think? Did they do a great job?
Thank you.
Thank you.
Thank you guys so much. We got to get him back to school. I think he's missed 2 days of school because of us, so we want to make sure we do a good job. Look, we've got lots of great partners in this area as well. On the tool side with Unity and Cocos, Trivia Cracks, Cut the Rope, Social Games. I'm addicted to Trivia Crack, I hate to say it. On the Monument Valley's got a new game coming out. So again, we've got folks pushing us, working with us, making sure we do a great job in this area. Look, as we get through this then, I want to come back around to conversations with developers. You saw a bunch of different ones today. One of the things that John and I do and our teams around the world is we'd like to get together and code. We run Hackfests. They're not competitions. It's not a hackathon. It's getting together with you and building things. All the companies listed here in groups are groups we've worked with. We have space up in Seattle that we use for doing this. I'm happy to announce that we're going to open a space here in San Francisco under the Reactor label. That's why I changed my rugby jersey, so that we have a space here. Obviously, I'd love to have space all over the world. We don't. But we are available all around the world. So we're going to make sure we show up wherever you are. The Reactor space will be here in San Francisco. We've got one in Seattle. And then as a team, we're going to take the content from Build, the things you're going to see the rest of the day and tomorrow. We'll be going to 26 cities around the world, try and show up where you are. In addition, we'll be either hosting or showing up at thousands of events around the world over the next year to bring everything you saw from Joseph's work to Kevin and David to everybody else that works with us in the company, the Office Graph, and all the other pieces. So with that, I want to thank you for your time today. We're going to have a maker video as our walk-off. The thing I'd like to say, I think, which Joseph has teed up, if our meme this morning was more code, then in the words of Christopher Walken, I think our meme for the rest of the day and probably next year is more cow. With that, I wish you well. Have a great day.
Making really is about sharing and about a lot of collaborators.
What I love about being a Microsoft maker is what Microsoft does to enable us makers here at the company.
You can come in and there are many different people from all different sorts of expertise and they can all help you out in various sorts of projects.
There's been a tremendous opportunity, especially in the last few years, of opening up beyond what Microsoft has traditionally focused on.
B15 is a robotics platform that we built in conjunction with the HoloLens team.
A lot of the IoT devices are headless devices. They don't have a display. But when you put on a HoloLens, that can become the display to not only view the rich data coming out of the IoT devices, but also to do command and control.
There are now an increasing emphasis on the Internet of Things here in the company. And as part of that, we had to build a platform for us to work on. Microframework has become the Microsoft answer for resource-constrained devices, with Windows providing a solution on up and larger devices.
When makers got a chance to experience Visual Studio 2015, they were delighted to see all of the capabilities and power of Visual Studio 2015 available for building IoT applications.
My son did a picture of the sun and tree and landscape. And what Virtual Shields allows him to do is to take their current location, go to the web, get the weather forecast, and actually turn on lights behind his picture on LED strip. It feels good to tie that into the Virtual Shield work I've been doing.
I've been building Tesla coils since I was a small kid, and it's been a great passion of mine. Because my Tesla coils are electronic, that means I can control them with some sort of electronic device. So I work together with Jason, who creates great music on his own free time. And then we created this project where Jason could have his Surface Pro bumping out beats and music, and this could talk to my coil and make them sing. I'm a maker.
We are makers.
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 We can't wait to see what you'll make.